All right, so it's time. So my thing says it's 11:20. I have this thing that I like to do where I like to start my talks at 11:20 and 59 seconds. That way, people can be late but still be on time. And, it's like that last minute. We still started on time, but that last person gets a chance to walk in. And usually when I say that, someone walks in just as I say that. But this time it didn't happen, and so they don't get to feel awkward. So, how's everyone doing today? How was the train ride in? I had to walk from the Hilton next door to here. It was cold for like 30 seconds. It was so difficult. So you're lucky I made it. So welcome everyone. This is Tracking Aircraft with Redis and Software-Defined Radio. I'll tell you up front, this is mostly about Software-Defined Radio, a little bit about Redis, because, well, I like both things, but Software-Defined Radio is Redis is really cool, but Software-Defined Radio is also really, really cool. So, my name is Guy Royse. I'm a developer advocate at Redis. I like to joke and say that there are three things that matter on this slide. And I think it's true, actually. There's a thing that matters to you, there's a thing that matters to me, and there's a thing that matters to my boss. And you guess what the thing that matters to my boss is? Yeah. I work for Redis. My boss would like you to know, and frankly, I'd kind of like you to know that Redis is more than just a cache. It can be more, it does much more than just have get set. Who here's used Redis? So about a third of you are willing to admit it. Who's used it as a cache? Who's used it as anything else? What do you use it as?
Kind of a queue between to exchange
Using PubSub as a queue, or using some people will use it as a queue using linked lists and stuff like that. So. Okay, yeah. So that's the second most common answer I get is some sort of queuing mechanism or as PubSub mechanism. I'm going to talk about Redis today. Actually, there's really only two things I hope you take home from this talk, and one of them is the thing that I care about, and one of them is the thing that my boss cares about. And that one thing is that he wants you to know, and is that Redis has an event streaming data structure in it. So if you've used Redis and you've used it as a cache, it can also be an event stream. I would not say that it's a full-on competitor to Kafka. They're the 800-pound gorilla. But if you're using Redis already and you need some event streams, they're there for your usage. So, and we're going to explore those a little bit today. And the other thing I hope you take away from this talk is that software-defined radio is really super, super cool. So that's the part that I care about. The part that you care about on this slide, the other part that I care about on this slide is my Twitter ID, because I try to get as many followers as I can. So give me a follow if you're inclined. But the part that you care about is the GitHub URL. So I've written a whole bunch of code. I've basically implemented FlightAware using Redis and software-defined radio and some open source software, some other open source software. And all of that is on my GitHub at github.com/GuyRoyse. So that's the part that really matters the most. So, and who here is a ham radio operator? Amateur radio operator. Any of you in the audience? No? Okay, well then, that's my call sign, but that's useless unless you're a ham radio operator. So, a couple of caveats before we get started. I am not an expert. I arguably might be an expert on Redis, some parts of Redis. Redis is big, but I'm not an expert on radio. I'm an amateur radio operator in the United States. I've got my general class license, which means I'm not allowed to operate here in the UK. I can listen to stuff, but I can't broadcast. I can't transmit. But I got my license about a year ago. I'm an enthusiast. And so there may be some subtle points in the radio theory that I talk about, in as much of it is its theory, that are perhaps wrong or not exactly right. It's because I'm not an expert. But I can give you the broad strokes and show you some of the cool stuff that you can do with software-defined radio. The other warning is that there's going to be a lot of demos. I basically have some toys here, and we've got 50 minutes, and we're going to play with them, which I think sounds like fun. Hopefully you all do too, right? Good. So there's going to be a lot of demos, so I'm going to be popping out of PowerPoint quite a bit. And this talk is a little all over the place. I've reined it in a little bit, but it still kind of covers a lot of topics. Because I built a cool thing. I built a aircraft tracking application, and here's the antenna right here. I mean, it's a hardware thing, and so, but it's also using software, and so there's a lot of parts. There's a lot of moving parts because I need to talk about radio. I need to talk about aircraft and what they transmit and broadcast to announce their location. I'm going to talk about event streaming in Redis, because that's how I save all of the data from the aircraft that I receive. And of course, that's part of Redis. So we've got a few topics that I'm covering. Again, the big parts here are we're going to talk about the software-defined radio and the cool things you can do with it, and we're going to talk a little bit about event streams. And it's probably going to be like a 80% radio, 20% Redis ratio, because I know what you really want. So, the first big question, what the heck's software-defined radio? Some of you may have been exposed to these, but many of you have not. You're probably here because you want to know what it is. Well, a software-defined radio is like a regular radio, but with less stuff. What do I mean by that? So what I mean is, like a radio has a bunch of circuitry and antennas to receive signals, electromagnetic waves from the air. But then it has to have circuitry to tune to specific frequencies, reduce noise, demodulate that signal to turn it into audio so that you can listen to it. And so there's a lot of extra circuitry there. And whether it's this really nice HF rig over here on the left, which costs about $1,200 US, or if it's the very cheap handheld Baofeng that costs $25 US, they are all doing these things. It's a radio that you plug into your computer. It has the circuitry to receive it, but it has the circuitry to decode anything. All that's handled by software. So there's less circuitry. This is a version of the radio I'm using today. It's receive only. You can get it I got it on Amazon for, I think, $30. It's got an antenna port on one side, USB port on the other side. And you might be wondering, how the hell did I get this stuff outside of the US on an airplane? Proper labeling. So, they really do look like ginormous thumb drives. So, the software-defined radio is the radio minus all the stuff that is used to demodulate those signals. And you use software on your computer to do the rest. And so, that's sort of in a nutshell what software-defined radio is. And I could talk about what it is more and more, but it's actually just easier to show you what it is. And so I have here, I'm not going to hold it up because it's plugged into my computer right now, but I have something similar to what you saw on the previous screen, except it's black. And I've got it hooked up to this antenna right here. This is an antenna optimized for the 2-meter band and the 70-centimeter band, ham radio bands. But it will pick up FM radio broadcasts just fine. And so we're going to listen to the radio. And hopefully, Devox doesn't get a copyright strike, because they're recording a YouTube video. So you should laugh so all the people on YouTube hear you. So, can you see that? It's a little light because the background's dark, but that's about to change. So I've got this tuned to a frequency that I tested earlier that had something playing on it. 93.2 FM. I have no idea. It looked like it was talk radio. They weren't playing any music. Hopefully they're not talking about what they were talking about earlier, because it was weird. But I'll go ahead and kick this off. And so you can see the radio signal coming down there, right? So this is coming from this antenna into my software-defined radio, which goes in via USB. And actually the computer kind of sees it like a sound card, but it's really wide. And so this can pick up a really wide swath of bandwidth all at once. It's not just a little narrow part. And you can see it's decoding this. It's showing it on the screen. It's not decoding, it's just showing it on the screen in a waterfall display. I'm going to go ahead and add a little, and I realize this is really tiny on here. The fonts on this are super tiny. I can't see them on my screen either. I just kind of know where things are at. So amateur radio is like this hobby it's kind of stereotypically the hobby of old men. And for the life of me, I don't know why they chose such a tiny font that I can't change, because I sure as hell can't see it. So let's go ahead and apply this.
A quick reminder that you can subscribe to the Briefing Room podcast by visiting BBC Sounds, and you'll get access
a little
to the
staticky,
entire back catalogue, including last week's on the latest on the war in Ukraine, the one about whether we should worry about the AI revolution, and in the wake of the
that's what software-defined radio does.
Airline Express has lost its contract over poor rail service.
This is a radio that you hook into your computer. You're like, well, that's kind of neat, but it's like radio, but with extra steps. What else can I do with it? Well, there are other things you can do with it. We'll talk about them in here. Let's go ahead and get my slides back up. For one thing, if you are an amateur radio operator, you can transmit, of course, but you can listen to other ham radio operators talk. Now, I've been trying to do this all week in London, and I haven't really found very many people chatting from my hotel room. I don't know if it's because my antenna's too small, there's too many buildings in the way or what, but I didn't hear anyone. But you can do that. There's lots of communication you can listen to. In the US, I can actually listen to police scanners because they're not encrypted and we're allowed to. I don't know if that's legal here or not. I suspect it probably is, but they're all encrypted so you can't hear anything anyhow. I know in Germany it's definitely illegal. In the US, I can also listen to air traffic control operators, so the tower talking to the pilots and stuff. But in the UK, I'm pretty sure that's illegal, even though it's in the clear and unencrypted. So you could totally do it, but don't. And hopefully I'm not breaking any laws by what I end up doing here today. If I get arrested at the end of the talk, just know that it'll be the most memorable talk you've ever attended. So, but yeah, there's lots of cool stuff out there to listen to. Well, that was my demo. So if you are already intrigued and wondering, how do I get this? Well, there's some kits out there that you can get on Amazon. These aren't links or affiliates or anything like that. This is just the things that I bought as I explored this. So the first thing I bought was this little RTL SDR kit with a few antennas. I think it was about $50 US. And that will get you started doing some basic stuff. You can start listening to doing stuff like I'm doing here. You can also do the aircraft thing that we're going to do later. And all sorts of fun stuff. So this is a really easy place to get started, very inexpensive. As I got into it more, I discovered that there's this HF stuff, shortwave radio. There's shortwave radio stations you can pick up. This software-defined radio does an okay job at it, but the antennas that I had don't. And so I went out and I bought an antenna optimized for those frequencies. And with this antenna and that little software-defined radio, I set it up in my dining room, and the antenna is just leaning against the kitchen window. And in Columbus, Ohio, in the United States, I picked up a radio station in Lhasa, Tibet, which is kind of amazing. And so that antenna was about $50. I think it's a little bit more expensive than that now. It's gone up. But yeah, great fun. And then where I finally graduated, and if I was to do this all over again, I would just get this kit by itself. Because the RTL SDR over there on the left, this one here, let's kind of get over there. This one here, it listens to the lower frequency stuff, but it's really not optimized for it. It's a little bit of a hack and it's kind of noisy. This device here on the right is an up converter. And so that big one right up here, I'm just going to point at the screen right there. And what it'll do is it's designed to listen to those lower frequencies and then we'll shift them up to a higher frequency that then that software-defined radio will pick up. And this comes with all the antennas you would want and some other things to make your own antennas. And so this up converter kit is probably what I would buy. And I think it's about $110 total. So not a super expensive hobby for us opulent software engineers. But this is the hardware that I've been using. This little thing down here is kind of fun. It's a Balun, which stands for balanced, unbalanced. I don't fully understand all the antenna theory behind it yet, but you can basically take a piece of wire and put it on the end of it and hang it out your window and pick up all sorts of stuff. So this makes it easy to make your own antenna. So that's the hardware. Not super expensive. I mean, not nothing. I mean, but some of it's like you can get started for less than the price of, dinner. So. For software, there's 4 major pieces of software that I found for that are general tuners, like the one you just saw me use. One is called SDR Sharp. Any clue what language that's written in, given its name? Yeah, it's definitely written in Perl. Yeah. So someone said Java, right? It's written in C#. It runs on Windows. It only runs on Windows. But it's pretty full-featured, and it's pretty nice software. It's got a nice plug-in architecture. GQRX is a little more simplistic, but it also doesn't require a ton of resources. This is the kind of thing you could run on Linux or on a Raspberry Pi. And so that can make a very, very cool combination. Cubic SDR is also fairly simplistic, runs on my Mac just fine, easy to use. But the one that I like to use, and the one you saw me using earlier, was SDR Angel. SDR Angel is kind of got a steep learning curve, but once you get into it, it's very powerful. it's got this sort of modular thing where it's like, I have my tuner and I'm picking my frequency, but then I have to select a decoder, and then it will select a frequency in that area, which is like that third window I popped up was that decoder, which was demodulating the FM radio. And it's got lots and lots and lots of decoders to choose from in it, including decoders that will decode data formats. There are lots and lots of data formats being broadcast around you all the time, and still in use. So some of them are used by amateur operators because they just like to communicate that way. People are still using Morse code. Morse code is compelling because at shortwave frequencies, you can get all the way across the world, and because it doesn't require a lot of bandwidth, you can get really far with not much power. So if the conditions are just right, people have gotten literally to the other side of the globe with 1/4 of a watt of power using Morse code, which is impressive. I don't know how to do that, but other more experienced hams do. Some like to use RTTY, radio teletype. This is, in essence, letters that are encoded. Like back in the 40s, they would send news reports from the field over radio teletype, over shortwave radio. There's still competitions where amateurs use it. There's also, you'll find like really loud RTTY frequencies when you start exploring, and when you try and decode them, it's all just noise. Those are usually military. Don't try to decrypt them because A, it's useless, and B, if you succeed, then you'll have another problem. And so these are a couple of the formats that are out there. One that I don't have on my list here, but I think is worth mentioning is the United States has a series of NOAA weather satellites, the NOAA, that they use to generate satellite images for weather reports. Well, we're using newer satellites now, but those old satellites are still up there. And you can use a software-defined radio like the one I have right here, and an old pair of rabbit ears from a television in just the right configuration, and pick up images from those satellites live. So you can get live images from space. How cool is that? Right? Everyone's like, I want to do that. I haven't successfully done it yet. I did it with an antenna that was unsuitable for that task. And it was mostly static, and this one little patch, I'm like, well, that could be a cloud. But, and the SDR Angel makes it really easy. Another data format that's very common out there is called APRS. APRS is an extension of AX25, which is packet radio. And AX25, if that sounds like it's vaguely familiar, who's heard of X25? Probably people over 50. So X25 is an old packet protocol. You're using it with Ethernet today. AX25 is that packet protocol extended to radio. And whereas like an X25 packet has your MAC address in it, your X25 packet has your amateur radio call sign packet in it as your address. And so packet radio could be used to establish TCP connections over radio. I have successfully checked my email over radio using AX25. I have logged on to a packet BBS. Who remembers the bulletin board systems that you would dial up to? I'm just really making a test to see who's old. Well, you used to dial up to them over the phone lines. Well, you can also do that over radio, and they're still out there. So APRS is sort of a simplified version of that, where you use that packet format that AX25 uses to sort of announce things. Like, hey, I'm a radio repeater, and I'm at this location, and this is my frequency. Or people will put them in their cars, or when they go on a hike, and their radio will say, I'm at this location, I'm at this location, I'm at this location. And they've got a location component to them. But you can also just send like text messages back and forth. So, and it's tied to the internet. So there's internet gateways that will pick up those packets and route them to internet servers. And so you can send packets from the internet that will exit to radio, and you can send packets from radio that will enter into the internet and sometimes come back out and route through the internet. So it's a really interesting network of communication that amateur radio operators can use. So vehicles will transmit their location of people walking around. There are lots of little weather stations that people will put on like the roof of their house, and they'll broadcast over APRS the weather information at that time. It's here's the temperature, here's how many centimeters of rain, that kind of stuff. And individuals can send messages out over APRS as well. And when they broadcast them, they are picked up by other individuals. Like we could attune my radio here to pick up some APRS packets, Probably with this antenna inside of this building, I'm not going to get anything. But you can do that. I've done it at home many times. Repeaters pick these packets up, and so if I broadcast a packet or transmitted a packet, a repeater might pick it up and then send it on to another repeater, so they'll hop a couple times. And there's a way to manage how that hopping works so that they don't reflect back at each other and create a loop. And I mentioned earlier there are internet gateways that route these things into the internet. Like one of the cool things you can use APRS for is you can send an SMS text message from your radio. So if you've got a little radio, I've done this from my computer, you can send a little message addressed to a particular APRS user that's on the internet, and they will then use probably Twilio, honestly, to then send a text message to that user. And then you can respond to that text and it will route back out to the user on the radio. So it's pretty cool stuff. In the US, it's at 144.39 megahertz. Here in Europe, it's at 144.8. And it's got other standards. And all this is routed in the internet. There's a website called APRS.fi where you can actually go and look at all of these. This is of my hometown in Columbus, Ohio. I live like right here. And this is just all the devices that were broadcasting the day that I took the screenshot. So APRS is really cool. It's very, I mean, it scratches an old school itch for me. It's sending data over the radio. It's kind of fun. Other data formats are AIS. We could probably pick some of these up, maybe. AIS is, excuse me, I need a drink of water. So AIS is information broadcast by ships and boats. So all the boats at sea, they broadcast information about their position, their heading, their speed, who they are. They use these two frequencies here. And I have picked up some boat traffic here in London because there's boats on the Thames that are using this. And so you could do this very easily with SDR Angel. And but also there's sites like FlightAware and FlightRadar 24 for aircraft. There's analogous flights for vessels. And a lot of this data is coming from satellites. So there's satellites that are picking up these transponder broadcasts and then feeding it back in to the internet so that we can all see it. And so if you like boats, this is a cool tool for that. And here's an example of Vessel Finder. So this is of the Great Lakes here in the United States, close to where I live. And what I like about this picture here is you can see that there's a fair bit of traffic on the Great Lakes when I took this screenshot. But down here, you can see the river. Like you can see over here, you can see the Mississippi River coming down because there's a lot of boat traffic on the Mississippi River. And you can see the Ohio River there underneath down here where I was pointing earlier. This is the Ohio River. So you can see it's kind of like those maps of the Earth at night where you can see where all the highways are at. It's similar, but with boat traffic. So neat stuff. All kinds of stuff out there to go check out. And the star of the show today, of course, is ADSB. This is data that all aircraft broadcast unless they've turned their transponder off. The only reason they would turn their transponder off is if they were a military craft and they didn't want anyone to know where they were because they were doing military things. So you can pick up military aircraft with this. I sure as hell hope that's legal here, and I also hope that I don't pick one up. But you can pick that up. I've picked up in the U.S. I've picked up military craft. I picked up police helicopters. But you can also pick up all the commercial flights, which is really kind of the star of the show. That's the bulk of the traffic. And the aircraft broadcast constantly, multiple times a second, at 1,090 megahertz ADSB data, which consists of their ICAO ID, which is a 3-digit, a 3-byte number, uniquely identifying them. There's data embedded inside of that you can extract. It starts with an A. It's an American plane, for example. A C, it's a Canadian plane, and other codes. Those are the only two I know because they're alliterative. Fun fact, this is Elon Musk's aircraft ID. I'm tracking you, Elon. They also broadcast their call sign. This is often their radio call sign that they use to communicate. But lots of times, if it's a military craft in the U.S., it tends to be some sort of just whatever they feel like putting in there. And so they'll put in like, Maverick or Iceman or something like that, right? I think the one I caught was like Jabber 55 or something like that. Or it's most often just their flight number. So this will be like Delta Flight 1234. They broadcast their altitude in feet. Internationally, I think that's kind of funny. They broadcast their speed in knots. They broadcast their heading in degrees, of course. And their location in latitude and longitude. And so all this data is being broadcast constantly. And so what I want to do is I want to show you how this works. And so the easiest way to do that is using this piece of software here. This is a screenshot from my home. Dabjet 55. That was a military aircraft. Right there. You see the Dabjet 55. But you see, this is all the data that comes out. This is a command line tool that coincidentally actually was written by the guy who created Redis. So it's written by Salvatore. I started putting together all this stuff and exploring it, and I'm like, oh, well, crap. That's perfect. That makes a great story. I can tell people that on the stage all the time. So, but yeah, so let's go ahead and I need to swap out my antenna here because this antenna that I have hooked up right now is optimized for different frequencies. And I have an antenna that's purpose-built for this, purpose. And so let me hook that up here, and we'll go ahead and get over to this has got to be shut off now. If I don't shut that off, it won't be able to connect to the SDR because it'll be two things trying to attach to the same device. So there we go. Let me hook up the antenna. These SMA connectors are nice, but they're so damn small. There we go. And if I run dump 1090, can everyone read that okay? It's a little small in the back probably, but we'll be okay. --net means it will open up certain ports where it will broadcast its information it receives over TCP so you can connect to it. And --interactive gives us a nice little display. So if I hit enter here, we've already picked up flights. We've only picked up a few. It's because my antenna is horizontal. And the broadcast from the aircraft, the antenna sticks off the belly. And so it's polarized. This is not polarized correctly. So if I pick it up like this, we should get more traffic. And yeah, we see quite a few. So yeah, here we got British Airlines flight 904, American Airlines flight 993. I don't know what PGT is. That's EasyJet, so I don't care about that. There's Ryanair. I also don't care about that. But yeah, so you see we're picking up quite a bit of air traffic. And it's got, the altitude, the ICOA number, the speed, the heading, the latitude, the longitude, et cetera, et cetera. So this is kind of cool already, right? It's all coming from this antenna. This is no internet. But if we want to actually consume this data, let's take a look at what it puts out. So dump 1090, and I'm going to embiggen this here. How am I doing on time? I got about 20 minutes left, right? Okay. It puts out data on ports 30,002 and 3. And if I go to 30,002, these are the hex messages that are coming in that is off the wire. And so you could easily connect to a socket on this port and consume these messages, parse them, and turn them into data. And you think, that's what you did, isn't it? No, it's not. Because dump 1090 is even nicer. How hard is that to parse? Right? It's a CSV file. It's actually even easier than that, though, because this CSV file is a standard format, and there's a Node module for it. And so I wrote a bunch of code in Node, and I just write an on message, and then it parses it and hands me all the named fields that I can just have a JavaScript object and go with. Pretty cool, right? So that's dump 1090. Notice it got faster. That polarization really matters. So let's go ahead and what's my next slide here? It's demo. Okay, so that's dump 1090. It's kind of cool in its own right, but it's not all the way there yet. We're almost there yet. So I have built something that's like FlightAware. And so I'm going to receive all these transmissions. They're going to go through dump 1090, and then I'm going to put them into Redis in an event stream. Every message from the aircraft is an event. I'm at this location. I was at this location. I was at this location. I was at this altitude. I had this heading. And so putting those in an event log is a very natural thing to do. And then I'm going to consume that event log and put them on a map. The version of Redis I'm going to use is Redis Stack. This is the one I use all the time. Redis Stack is the regular old Redis that you've been using all the time, but it's got a couple extra capabilities. It's got JSON data structures. It's got search capabilities. It's got probabilistic data structures, and it has time series data. I have search elements in what I've built here, but I'm actually not using any other than that. I'm not using these features. I'm not going to show the search stuff. I don't have time. So what I've built is sort of this massive, allegedly microservice architecture. Honestly, given the way things are going right now, I probably should have built this as a monolith. That's what all the cool kids are doing now again, isn't it? That's what I've heard. So I've got a series of services running that are radio ingesters. What these do is they talk to dump 1090 and consume that data, and they shove it into a stream in Redis. And I've got there can be multiples of these running and publishing to the same stream. And this is nice because then I can have I have a coworker in Nottingham, and I've got a coworker in Seattle. And sometimes I don't get signal because I'm in a room where the signal doesn't work. And so I can have them run it and point it at a cloud version of Redis, and then I can still have something to show even though I can't pick up any signals. We got lots of signals, so we don't have that problem today. And so I'm running Redis locally on my machine. So the radio ingester shoves these into Redis, into a stream. I have a radio consumer which consumes that stream and then populates hashes in Redis that show the most recent information on that particular flight. So its most recent location, its most recent altitude, etc. I have a flight API that then exposes that information in a simple REST API. I also consume that stream and create what I call flight events. This is just a simple little web app that publishes a WebSocket that says this aircraft ID, this location, all that data, so that I can build a map. Together, I use a little UI that actually has the map on it. I'm using Leaflet and Mapbox to do that, and just plain old JavaScript. No, not using any front-end library. I'm just, document.onEvent. And then I got a little gateway through in front of all that to make it work, so they can all see each other. We're not going to go into details on all these pieces, parts, because quite honestly, that would be tedious. But I'll show you the radio ingester. I've got the code up here on the slide. This is a Java conference, and I've got JavaScript code, so I think I'm just going to skip the code, if you don't mind. I know it's bad enough that I have to go home at night and cry. So we'll skip the code, but let's skip this here and here. But I will show you the Redis commands behind the scenes that make this possible, and then you can translate this to Jedis or Ledis or whatever client libraries you use. So ultimately, I'm connecting to Redis, and I'm connecting to dump 1090 using that node library I was mentioning. I wait for messages, I process them, and then this is just a bunch of, hey, the date's in a weird format, and the latitude might not be there, and it's a lot of code like that. It's nothing clever. We'll talk a little bit about the streams that I'm actually publishing this data to as I receive it. So who here has used event streams or are familiar with them? About half of you? Okay. Well, for the half that hasn't, I'm going to give a sort of a really quick idea of what streams are, and then I'll show you the commands to interact with them, and then we'll do the demo. Sound good? Okay. So you can think of an event stream as I like to think of them as log files, but they're things that have happened in time. And they're by definition sort of in the past. This thing happened, and we want to store a record of it. And we have data associated with it, and we have a timestamp, or we have a time that event occurred. In Redis, we got this little event. There's a little data next to it. And in Redis, we assign each event an ID to uniquely identify it. And the ID that comes for the next event will always be later than the past one. And so this is how they're ordered. And so that ID in Redis is made up of a Unix timestamp in milliseconds with a sequence number in case you get more than one a millisecond, which totally happens, especially with the aircraft data. They come in pretty quick. And we just start stacking these messages up. So in like our aircraft example, this timestamp is literally the time that we received that message. And the data is the information that we got from dump 1090. It's the latitude, it's the longitude, it's the altitude, altitudes. And we just start stacking these messages up as they come. And now you have like a log or a recording of all the things that happened. And you can use these streams to as sort of like a queue and just say, well, just tell me when there's new stuff that arrives on the stream, and I'll do something about it. Or you can go back to the beginning of time and replay these streams. And so, it's a very powerful metaphor. It's not for every problem, just like any technology, but that's what streams are in sort of a 30-second rendition. To use a stream in Redis, there's just some Redis commands. Here I'm calling xadd. And I give it a stream name, which is a key in Redis. I give it star for the ID because I want it to generate an ID. I can override that ID behavior, but by default, it just generates it with the timestamp. And then you give it key value pairs. So here we have Elon Musk's airplane. To read the stream, we use the xread command, and we give it the name of the stream and the key we want to start with. If we give it 00, that'd be the beginning of time, and this will give you This command right here will return everything that's been added to the stream since it started. Probably not a command you want to run if there's a lot of data there. Here we add another one. And you can also say, well, hey, let's add give me all the things after a specific time. You can give a count and limit it so it doesn't give you, a million events. It just gives you 10, and so you can read it in batches. And so here's the code in JavaScript to do that. The events are the other end of the stream. So this is adding things to the stream and doing a quick just look at it. If we want to add things, wait for events in Redis for a stream, we say xread with block. And what block will do, we'll say wait up to however many milliseconds until something appears on the stream. If you give it this magic number here of the $sign right there, that means give me something new that's after the end of the stream. So if you say, you basically can sit on the end of the stream and wait for something to happen. And so this is the most common pattern you'd be using. This is what I do with the WebSocket. And so then I call the $, I add something, and then it responds with that thing. And then subsequent calls would be, you wouldn't want to do $, you'd want to do that ID of the message you just got, because that will get you everything after that. If you do $, again, things can come in before you call again, and you could miss messages. So you sort of kick it off with the $sign, then you start passing in the ID each time you receive it. So that's sort of the streams component for Redis. Super quick. Here's more JavaScript code that you don't care about. Processing the event. Blah, 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 blah. JavaScript, JavaScript, JavaScript. Cry, cry, cry. This is okay. So this is the WebSocket code. I'm not going to bore you with all that code. What I'm going to show you next, because we've got about 12 minutes, and there probably will be questions, is I want to show you what I built. I'm not going to look at the code. We're just going to show you it running. You can go out and get the code yourself. It's all out in GitHub. So, not there. So dump 1090 is still running. Over here, I'm going to run the radio ingester with just a quick Docker compose up. And this radio ingester is now reading things from the antenna and shoving them into Redis. We can prove that if we go here into Redis. This is Redis Insight. And you see I've got a stream now. If I click on that stream, I can see that there should be records in it. Come on, don't make a liar out of me. There we go. It was just below the fold. So it's adding records here. So we see we got 11:59 and 1 second from Radio Devox UK, that aircraft, and a bunch of all the data about it. This has got, looks like this just has the fact that it exists. And if I refresh this, you see that it's now 59 minutes and 26 seconds, and we know that's, so we see the airline, that's British Airlines Flight 91J. So we're getting data coming in. Cool. So let's go ahead and launch the second part of it. And this is the rest of it. I guess I don't have it in my history. Docker, compose. And what this is going to do is it's going to run that radio that stream consumer that's going to start populating hashes in Redis, and it's going to run the user interface and the WebSocket component and everything. And if we go over here to Redis now and refresh, we see we got a bunch of keys here for the different aircraft. So now we've got information about those aircraft. But that's not really the cool part. The cool part is that we have a little app running at localhost port 8080 that wants to know where we're located. There we go. And so this is the aircraft that we're picking up right now. Let me go ahead and lift this up and see if we can pick up some more. Yeah, a couple more popped up. This probably won't work as well as it did in the auditorium, in the main hall out there. But these are, so we're right here. This aircraft right there doesn't have a flight number. That doesn't either. That's Ryanair Flight 38QK up near, the plane's blocking it and I don't know the geography, so I don't know the name of the place. Something, Hemel Hempstead, yeah. There is United Airlines Flight 947. And I've actually got links here. If you click the it's a little fiddly as they move around. Click on this one. So this is my little REST API that gives you the flight data that's in those hashes. That's all written in JavaScript. If you click on this link here, it will take you to FlightAware. And then you can find out more details about the flight. But it's going to Faro, which is not what I expected. But yeah, so, and I can't stress enough how fun it is to watch this, because these aircraft are moving around on this little map here, and all of the data is coming from the magic wand that I'm holding in my hand. The maps are coming from the internet, but all the data that we're displaying is from here. It's just out there for the taking. And oh yeah, we're picking up a little further out now. Up here, that looks like it's a ways out. Like I said, I did pick up stuff in the channel. If I had this on the roof of the building, we would probably pick up stuff from Kali. So not a problem. So, but yeah, that's my little demo. I think it's cool. You should go buy all this stuff and then run this stuff yourself too. So I'm going to go ahead and go back to, one fun tidbit. So you know how I made these planes rotate? Some of you may have been in the Redis booth the other day and found out. But you'd think I did a CSS thing to turn them. No, I just created 16 icons. It was all way easier, honestly. Low tech. I years ago, early in my career, I was in my 20s. He was like a year from retirement. Wise guy I worked with, wise guy and wise man. I guess both of those things. Said that low tech is go tech and high tech is die tech. Something I've always remembered. So, any questions before I have a couple CTAs? Yeah.
I was wondering, what did you use for the map?
What did I use for the map? I used Leaflet, which is just a JavaScript front-end library, actually written by a Ukrainian developer. So when you go there, they ask you to support the Ukraine, which is awesome. And Mapbox behind the scenes for that. And so actually, if you go to my GitHub repo, the key for my Mapbox account for that demo is in there. I don't care if you use it. It doesn't cost me anything. Any other questions? You're stunned. Oh, I was going to make the joke about you being silent was really reassuring, but yeah.
Thank you. I just want to ask how many hash map are you creating? Are you creating every packet that is getting in? You create the hash map?
So the question is how many hash maps did I create? Do I create a hash map for every packet that I receive? I do not, because every packet has an aircraft ID associated with it. And so what I do is I'm merging the data into the existing aircraft ID. So I'm just overlaying it each time. The stream has an entry for every single packet I receive. And so there's a lot of those. And then I have an expiration settlement in Redis so that they expire after 5 minutes so that I don't fill my hard drive up. Because it is quite a lot of data. So, but yeah, so good question. Yes, sir.
Could you draw the lines where the plane was?
Could I draw the line where the planes were? Yeah, I could do that. I didn't. That'd be hard. I thought about it actually, and there are software packages that will integrate with Dump 1090 that will do that. And there's even ones that will do a little shadow under the plane to give you a sense of elevation, which is kind of nice too. So you could get very elaborate with this. I just wanted to get them on a screen, and then I was pretty happy. The other thing you could do that I thought about was FlightAware has an API that allows you to look up the aircraft information. And there's actually another Open Sky Network has a CSV file you can even download that does that too. And so you could look at the aircraft and say, is that like a Cessna or is that a 777? Or is that a helicopter? And you could change the icon out as well. And so you could actually display a lot more information. But I didn't want to get too elaborate with my little project here. I probably should make a Java version. Other questions? Did I see a hand? Yeah.
Little bit way of question. Since you need a license to broadcast stuff, why can't we? Why didn't we hear about more people poisoning the broadcast? Because you just need a license. License means you are allowed to, but physically you can't do it.
So the question is if you just need a license to be able to broadcast or transmit, more accurately transmit, why don't more people create fake data for aircraft data? Because they'll go to prison. That's the bottom line. It's not like it's hard.
Yeah, it doesn't stop people like
Yeah.
holding a gun and killing people. So why don't we hear more about people poisoning the
Yeah. I think the reason why, I'm speculating here, I don't really know, right, is I joke and say because I'll go to prison, but that is true, right? That will happen. It's a big deal. In the US, if you transmit without a license on ham radio frequencies or frequencies you're not supposed to, it's like a $10,000 fine. And if you start messing with aircraft navigation data, the FAA gets involved, and then it starts turning into jail time. I think part of the reason, though, is that most people don't know they can. It's a little bit of security through obscurity. I mean, all this data is unencrypted, and it's unencrypted by design because it's the risk of running into an airplane is greater because of the transponders not working than the risk of something bad happening because someone had that information. And so that's basically the trade-off that's been made with this. So people don't poison it. You just don't see it. You certainly could do that. It wouldn't be that hard. But people in practice, it just doesn't seem to happen. And maybe we're lucky. I think it's obscurity. So I'm going to go ahead. We got 3 minutes. So here's some resources for you to check out. The link to Redis Stack, which my boss and I honestly want you to use. We got the SDR software over here that I use, links to it. And these slides are in a GitHub repo, so you don't need to make sure you get this if you don't want, because here's the AIS trackers, the ADSB trackers online. And then that's the GitHub repo for Dump 1090. I work at Redis. We've got a Discord server if you got Redis questions, discord.gg/Redis. We got free classes at university.redis.com. I think one on streams even. And you can get a cloud version of Redis at redis.com/tryfree. This is the link you've all been waiting for. It will take you to that URL and only that URL. This QR code will never give you up or let you down. Or run around and take you to some site that it's not supposed to. I totally want to rickroll an audience someday, but I can't bring myself to do it. Maybe my next project will be a rickroll Bitly. So, that's all I've got. I guess I got time for one more question real quick. Although I see people milling about outside, so maybe not. Thanks a lot, everyone.